Hey everyone, welcome back to the channel. In this video, we are going to learn about Kirchhoff voltage law. This law is essential for understanding how the voltage behaves in a closed circuit. Let's get started. Kirchhoff voltage law states that the algebraic sum of all voltage around the closed loop is zero. Let's try to understand this. If you look at this circuit where the power source is connected with three resistors, so the voltage will be divided V1, V2 and V3. According to the Kirchhoff law, in a circuit with a loop like this, we can say that V is equal to V1 plus V2 plus V3. Let's try to prove this. Now, if you look at the loop direction and the voltage direction, both are same. So, we put that as plus V. But the loop direction and the V1 direction is in opposite direction. So we put as minus 1. Similar to that one, the loop direction is going this way and the V2 is upwards. Again minus V2. Similar to that one, loop direction is going this way, V3 is going upwards. So V3, which should be equal to 0. If you rearrange this formula, then you will get V is equal to V1 plus V2 plus V3. Now you might be wondering how to define the direction of the arrows. In terms of loops, you can either put clockwise direction or anti-clockwise direction. But when it comes to voltage across this power source or the voltage across the resistance, you have to always put the arrows from your low potential to high potential like this. For example, in the power source, this is the high potential, this is the low potential. That's why the arrow will be from minus to plus. For in the resistor R1, this is the high potential, this is the low potential. So the arrow will be from minus to plus. Same as that one for R2 and R3. Always your voltage direction will be from low potential to high potential. Now let's dive into a question. In this question, we will try to find out the value of V1 and value of V3, where your voltage across the power supply is given 12 volts and the voltage across the R4 resistor is 8 volts and the voltage across R5 resistor is 2 volts. Now, if you consider this as the loop 1, loop we call it this as A, and the second loop we call it as B. If you apply the KVL for a loop A, then the voltage direction across the power source and the loop direction is in the same way. So it will be plus 12 volts and the loop direction is this way. V1 direction is opposite to that one. So it will be minus V1 and the loop direction is this way and the V2 direction is opposite to that one. So again it will be minus V2 will be 0. V1 will be 12 minus V2 where 12 minus V2 is 8 volts, so it will be 4 volts. On the other hand, if you apply the KVL for the loop B, then the loop direction and the voltage across the R4 resistor both are in the same direction, so it will be 8, and the loop direction is this side, V3 direction is opposite to that one, so it will be minus V3. Similar to that one, the loop direction is downwards here and the R5 voltage across R5 is upwards, so it's minus V4, that will be equal to 0. So V3 will be 8 minus V4 where V4 is 2 volts, so voltage across V3 is 6 volts. We can confirm these results by considering a third loop around the circuit. Let's see how it's done. If we consider third loop around the whole circuit, which is C, then if you apply the KCL for the C, then the voltage across the power source and the loop direction is in the same way, so it will be 12, but the loop direction is this direction, but the voltage across R1 is opposite to that one, so it will be 4, same as that one. Loop is direction is in the right side and the voltage across R2 is left side, so it's 6 volts, and the loop direction is downwards here, and the voltage across R5 is upwards, where again this is -2. So -4 -6 -12 is 12 minus 12, which will be 0. Thus it's confirmed the algebraic sum of all voltage around the loop will be 0. Let's try to find out the value of V1 and E2 in this circuit. In here we have two loops where I will put the loop A is in clockwise direction and the loop B will be in anti-clockwise direction. If you apply the KVL at loop A, then the voltage across E1 and the loop direction is in same way, so E1 minus, because the loop direction and the V1 direction is in opposite, so minus V1, same as that one, minus V2, why? Because of the loop direction and the voltage direction is opposite, will be equal to 0. So from here V1 will be E1 minus, instead of V2 it's 6. So E1 also 10 minus 6 will be 4 volts. On the other hand, if you apply the KVL at loop B, then the voltage across E2 and the loop direction is in the same way. So E2 minus V3. Reason is the loop direction and the voltage direction is in the opposite. Similar to that one, the loop direction is here and the voltage across V2 direction is opposite. So it will be minus V2 will be equal to 0. From here E2 will be V3 plus V2. V3 is 8 plus V2 is 6, where you say E2 will be 14 volts. We can verify these results by considering the outer loop. If you consider outer loop around the circuit like this, according to the KVL, you can write the equation as E1 minus V1 plus V3 minus E2 will be 0. Instead of E1, it will be 10 minus V1 is 4 plus V3 is 8 minus E2 is 14, where the sum of everything will be 0, which confirm the earlier results. So that's all about Kirchhoff voltage law. If you enjoyed learning, give this video a thumbs up and share it with your friends. Don't forget to check out the previous video on Kirchhoff current law. Until next time, keep learning.